In our modern life, we are constantly moving, whether that is by car, by foot, or even by bicycle. But what we never realize is that we are actually moving at several different speeds at any given moment. Relative to the floor you're currently standing on, or the chair you're sitting on watching this video, you're not moving at all. In fact, you're at rest. But when we begin talking about how fast our planet is spinning, we're actually moving 460 meters per second, or 1,000 miles per hour, around the center of our planet. So technically, you could say that you're actually moving faster than the new Bugatti Chiron, which has top speeds of only 133 meters per second, or 300 miles per hour. If we move things up a notch, then we could talk about our speeds relative to our sun. In this case, we're moving 30 kilometers per second, or 67,000 miles per hour. So you could also brag about being faster than the rockets that are currently being used to fly astronauts into space. In all cases, we are right in saying that we're not moving at all or that we are moving at extremely high speeds. That is the basis of Einstein's theory of relativity, that there are different perspectives, meaning that everyone is right, but everyone is technically wrong at the same time as well. I know, amazing, right? In our definition, there was a word that will lead into more depth about Einstein's theory: time. Time is a relative measurement, meaning that we actually made up units like seconds and hours, but that does not mean that time does not have different perspectives as well. The most simple way to explain this is our understanding of what is needed to reach the speed of light. Einstein has already theorized that on the way of reaching the speed of light, you would gain infinite mass, which in turn would require infinite energy to accelerate to such speeds. Now we must add the new piece of our puzzle, which comes from our proven knowledge that light is actually affected from objects like a black hole or a neutron star, which are infinitely massive. Light either bends around them or gets sucked in entirely. This allows us to assume that mass or gravity, which is a resultant of mass, can actually affect light. And for the last piece of our puzzle, we know that as we move at light speeds, time around us slows down. What will have been just a few seconds for us to reach Mars from Earth at light speed would have actually been 22 minutes for the universe around us. So taking all of this in, we can say that we gain infinite mass from moving at light speeds, which in turn bends lights around us, and when we have achieved light speeds, or infinite mass, time basically slows down or stops entirely around us. From this we can see a direct correlation from gravity, our resultant of mass, to time. So more mass equals slower time than the rest of the universe, or faster time in the universe around us. Either version is right. Now you might ask me, what even is this? How can this even be relevant to us? Well, let's look at a scene from Interstellar. There it is explained that there is a planet on which an hour is 25 years back here on Earth. So when our main hero spent an hour surviving there, his daughter aged 25 years back here on Earth. Where can this be applied? Einstein's theory can be applied to get a better grasp of astrophysics and better accuracy in space travel at light speeds.